Right now, part of your visual world is a blank spot. The room you are looking at appears smooth and continuous, but in each of your eyes, at a patch roughly 15 degrees off to the side, there are no light-sensitive cells at all. The hole has been there your entire life. You have never seen it because your brain is painting over it, live, with details it invents from the surrounding scene. In 10 seconds, you can prove the hole is real with a piece of paper and a dot. Once you find it, you will never trust your eyes the same way again. The story of the hidden hole begins in France in 1668 with a physicist, a king, and a simple optical paradox. That physicist was Edme Mariotte, a member of one of the first great scientific academies, and he was already a careful student of vision. In 1668, he performed a peculiar experiment. On a sheet of white paper, he placed two identical black discs, separated by a distance. Then he covered one eye and fixed the open eye on the left disc while moving the paper back and forth. At a certain point, the right disc vanished completely. The paper underneath it stayed visible, smooth, and white, as if the disc had never been there. Move the sheet a few centimeters closer, and the disc snapped back into existence. Mariotte repeated the result in front of a crowd at the French court, with the blessing of Louis XIV. This was not a trick of light or a defect in his eyes. It was a hole built into every human eye. That hole is called the blind spot, and its formal name is the optic disc. The back of the eye is lined with photoreceptor cells, but they do not cover the surface evenly. The neurons that collect their signals eventually gather together like wires into a cable, the optic nerve, which must pass through the retina to leave the eyeball and reach the brain. At the exact point where the cable punches through, the rods and cones are pushed aside, and no light detection is possible. The optic disc is about 1.5 millimeters wide. In visual terms, it covers a rough oval of about 5 degrees, wide enough to hide many full moons at once. A hole of that size should be obvious. It is not, because the brain has been covering it up since the day you were born. This covering up was Mariotte's second discovery, before anyone had a word for it. When the right disc disappeared, the white background did not disappear with it. The observer did not see a dark gap, a black shadow, or any interruption at all. The visual system was doing the same thing that it did with the rest of the scene. It assumed the paper was white and continuous, and so it manufactured the missing patch of white from nothing. Today, this process is called filling in. The visual cortex receives no signal from the optic nerve head, but it also never receives a signal saying that something is absent. It simply treats the empty patch as a region of unknown content and stitches it over with the most plausible pattern based on the immediate surroundings. Perception, even at the simplest level, is an act of invention. The invention was not always a plain white sheet. Mariotte moved his discs around, placed a candle behind the sheet, and tried different colors. The filled-in patch took on the appearance of whatever material bordered it. If the blank disappeared on a colored background, the brain replaced it with that color. If a line passed through the blind spot, the brain extended the line across the gap. This is why the hole has been so hard to notice for all of human history. The brain is an expert at continuing lines, colors, and textures into space that does not exist. It did not take long for other experimenters to confirm Mariotte's result. Within a decade, the blind spot was accepted as a fixed part of human anatomy, but its deeper meaning took another 200 years to be drawn out. In the 1860s, the German physiologist Hermann von Helmholtz built the missing theory. Helmholtz argued that perception is not a mirror held up to the world. It is a process of unconscious inference. The brain is constantly forming a guess about what the scene must be, using the fragmentary data the retina provides, and what you consciously see is the result of that guess. The blind spot was his favorite evidence. Here was a part of the retina with no data at all, and yet the visual experience had no hole in it. Something inside the nervous system was filling the gap with a prediction. Helmholtz called it an unconscious inference, a term that sounded strange then, but it is exactly how modern perception science frames the way the brain works today. Mariotte found the hole. Helmholtz explained why no one sees it. The experiment that pinned the phenomenon down came in the late 20th century from the neuroscientist Vilyaner Ramachandran and his colleagues. They used the blind spot as a controlled window into visual processing. In one class of experiments, they arranged simple shapes so that part of a figure fell entirely within the blind spot. Observers did not report seeing a broken figure. They reported the shape as complete, and the brain filled in the missing contour in a very particular way. When the surrounding lines suggested a circle, the observers saw a circle. When the same fragments could be read as a square, they saw a square. The filling in was not a random blur. It was a structured interpretation, obeying the same rules of contour, color, and continuity that organize the rest of your vision. This was Helmholtz's inference made visible at the level of a single missing patch. Brain imaging studies have since followed that inference into the cortex. The visual cortex contains a map of the retina, and the region of the map corresponding to the optic disc receives no direct visual input. Yet when a person perceives a figure completed across the blind spot, that cortical region becomes active. The activity comes from feedback from higher visual areas, which send predictions back down to the map and fill the gap with an expected image. The neurons in the empty patch are not silent. They are being driven from the top down. This is one of the cleanest demonstrations that vision is a two-way street. Sensory data flows upward, and expectations flow downward, and the two streams meet to produce the seamless picture you experience every waking second. So why do you never notice the blind spot in ordinary life? The first reason is that the two eyes cover for each other. In your right eye, the blind spot lies in the part of the visual field on the right. In your left eye, it lies on the left. When both eyes are open, the missing patch in one eye is supplied by the other eye's view of the same part of the world. The second reason is movement. Your eyes are never truly still. They jump from point to point several times a second in quick motions called saccades. Each saccade sweeps the blind spot across a different pocket of the scene. The brain then stitches together a stable picture from hundreds of overlapping samples. The whole is always moving, and the brain is always resolving it before you can notice it. You can make the second reason irrelevant with a simple test. Take a small piece of paper. On the left side, draw an X about 10 centimeters to the right, draw a filled black dot. Close your left eye. Use your right eye to stare directly at the X and hold the paper at arm's length. Then slowly bring the paper toward your face. Keep your right eye locked on the X at some distance. The black dot will vanish. It will not fade gradually into gray. It will disappear entirely, and where it was, you will see the clean white paper of the card. Bring the card a fraction closer, and the dot will pop back as if it flickered. The whole demonstration takes less than 10 seconds. When the dot disappears, you are looking at your blind spot from the inside. The paper around the dot is sending light to your retina, but the dot's light is landing on the optic nerve head, where nothing can be detected. Your brain has already measured the white paper on either side of the gap and extended it through the hole. You are not seeing a hole. You are seeing a prediction. Notice that the paper is not just blank. It matches the brightness and grain of the actual paper around it. If you slide the card sideways slightly, the dot can appear to shrink on one side before vanishing, as if something has swallowed it. It feels unnatural at first, because it is the only time you can directly confront a gap your own brain refuses to show you. The filling in is powerful but not unlimited. It loses its grip under one condition. When the missing area borders an unusual or ambiguous pattern, the brain has to choose what to invent, and sometimes it gets the invention visibly wrong. If you place a single small shape so that it straddles the edge of the blind spot, what you see is a strange hybrid, a shape that appears to stretch and compress. If you move the card, the shape can change its contours entirely. There is no truth filter in the gap. The brain simply produces its best guess, and because it has no signal from the whole to correct that guess, the guess itself becomes the final version of reality. This is why the blind spot is so valuable to research. It is a way to watch the visual system's assumptions in action, unconstrained by evidence. Those assumptions are everywhere. The blind spot is not the only place where your eye hands the brain a blank sheet. At the center of your retina, the fovea, you have a small region of high resolution surrounded by a vast periphery that is remarkably poor at detail. Your eye moves around the scene, and the brain uses memory and inference to turn those snapshots into a continuous, detailed world. Even your color perception is partly invented. The periphery of the retina has almost no color receptors, and your brain fills in plausible colors from context. The blind spot is the most dramatic example because the gap is hardwired and stable. But the principle is general. What you see is a model of the world, not a transcript of it. Mariotte could not have known any of this. He had no microscope powerful enough to see the anatomy clearly, and he lived 2 centuries before the word neuron existed. But his demonstration did not require electron microscopes or brain scans. 2 black dots, a sheet, and an open eye were enough to prove that the eye contains a whole, and that the mind will lie rather than admit it. In the decades that followed, his observation helped settle a long argument about where vision actually occurs. The lens of the eye focuses light, but the retina converts it into nerve signals, and the blind spot, which is the nerve's doorway, is the site where that conversion fails. The eye is not a passive instrument. It is an active, flawed, gifted machine. So the next time you look at a face, a window, or a screen, realize that part of that view does not exist. Your brain has just finished brushing paint over a hole you were never meant to find. Now you have found it. You may not be able to call it up at will, but you will always know where it is. And that knowledge changes what it means to see. You are not receiving the world. You are composing it, one small patch at a time.